Thanks for joining us on 90s Plus. I'm Chris Bianchi. It was a stunning sight across Colorado skies on Sunday night and Monday morning. A rare aurora borealis was clearly visible over parts of northern Colorado, dazzling the skies with a spectacular light show. But how does the aurora borealis form, and how rare is it? We spoke with Ron Ranach from the Denver Astronomical Society for more insight on the aurora borealis.
The aurora borealis and the aurora australis are what are called northern and southern lights, respectively. And they occur when particles from the sun, primarily protons and some electrons, arrive at the Earth from the sun and follow the magnetic field lines that surround the Earth, and then reach the polar regions and interact with molecules in the Earth's atmosphere. And that produces these spectacular colors that can be seen during some of the northern and southern lights. They're typically aurora in what's called an auroral oval at both poles, actually the magnetic poles of the Earth, the northern and southern magnetic poles. So they're there most of the time, but they can really be enhanced like they were last night, in particular by a solar flare that generates what's called a coronal mass ejection. And think of that as billions of tons of plasma with an embedded magnetic field that blasts out into space. And if that coronal mass ejection, or CME, happens to be Earth-facing, when it arrives at the Earth, then the protons and electrons in that CME can follow the magnetic field lines, just like the particles from the sun normally do, and interact with the molecules in the Earth's atmosphere. But a big enough CME can result in the northern and southern lights being seen at latitudes that they're not normally seen. For example, the CME that arrived at Earth on the 26th was strong enough that it produced visible aurora seen in northern Colorado. So that's pretty spectacular. It doesn't happen that often, but it does happen. And of course, when it does, it tends to catch people's attention. That CME was accompanied by some incredibly strong solar winds. They exceeded 800 kilometers per second, which is a velocity that hasn't been seen, I think, in a long, long time. And if we translate that to miles per hour, that 800 kilometers per second is roughly 1.7 million miles per hour. So that's a really strong solar wind. So we have the combination of a very powerful solar wind with the CME and its arrival at Earth, and that was enough to give us a spectacular light show visible in Colorado. It also created what's called a G3 class geomagnetic storm. And basically, when the CME and the solar wind smacked into Earth and its magnetic field, it caused a magnetic storm. And a parameter called the planetary K index, or KP index, which is a measure of the strength of a geomagnetic storm, hit 7. That's a pretty good sized number, and that's usually a good indication that we have a good chance of seeing northern lights here in Colorado. And last I checked just a few minutes ago, the KP index was still 7. I expect that will probably settle down, but we'll have to wait and see. So there's a possibility that people might be able to spot the northern lights again tonight. So fingers crossed for that, but it all depends on what the sun does. It is possible to predict the arrival of a CME. Scientists do study the sun, and we've got probes out in space that track and monitor the sun's activity. And when a solar flare occurs, or when a CME occurs, or when both occur, or when something called a coronal hole occurs on the sun, which can cause issues, these are all precursors to potential issues with geomagnetic storms here on the Earth. And all of that falls under a branch of science called space weather. And scientists are especially interested in it because severe space weather can affect satellite operation. If it's severe enough, it can affect the electrical grid operation on the surface of the Earth. So these are all things that are very, very important. And of course, it can also affect aircraft that take polar routes, because that tends to be where a lot of that energy is the greatest. And so they'll reroute what are typically a polar or transpolar flight to a more southerly latitude where it's safer for the high altitude aircraft. The answer is yes, you can possibly predict it, but you really need to track a couple things. And one is the speed of the solar wind, and the other is the KP index. And a good website for people to check out for that information is called spaceweather.com. That site has the current speed of the solar wind, and it also lists the KP index. And if the KP index gets, let's say, at 7 or higher, that's a good chance to see northern lights from Colorado. And also look for the solar wind speed of, let's say, 600 plus kilometers per second. I also use an app called Solar Monitor, which takes information from NOAA from the space weather information that they provide, and it posts alerts and whatnot. So I got the information on an alert from my phone this morning from that app that said, "Oh, KP index is 7." I thought, "Oh, this is good." And then I saw the posts and some of the photos and whatnot that people had taken last night that said, "Yep, that makes sense. KP index is 7. Solar wind speed is up. It was 800, way over, but over 800 kilometers per second. That's a nice coming together of a couple parameters that really contribute to our being able to see the northern lights from Colorado. The sun right now is nearing the peak of its 11-year sunspot cycle, and I love to take a telescope out each day we have a clear sky and take a look at the sunspots. And oh gosh, the last several months we've had a lot of sunspots, and people say, "Well, what's a sunspot?" And it's a spot. Well, it looks like a spot on the surface of the sun as seen through a safely filtered telescope, and it looks darker than the surrounding area, so it's called a sunspot. These things can be several times the size of the Earth. Say people then might ask, "Well, what the heck is a sunspot, or what causes it?" And it's caused by magnetism on the sun. Just like the Earth, the sun has a magnetic field, but it's much more complex than the Earth's magnetic field. And when you see a sunspot, that's a location where the magnetic field lines have become really, really concentrated. So try to visualize a rope sticking out of the sun and going back to the surface of the sun, and except instead of a cotton rope or something, that's actually very, very highly concentrated magnetic field lines. And the magnetism is so concentrated that it actually suppresses convection on the sun. So the sunspot can be a couple thousand degrees cooler than the surrounding area. Now, it's still hot and it's still bright. So we see that dark spot through a filtered telescope. It's still very bright, but it's all relative. If you could somehow take that sunspot off the sun and look at it separately, it'd still be bright enough to blind you. But where that magnetism is extremely concentrated, it can sometimes result in a solar flare. And when the solar flare happens, that can result in a coronal mass ejection. So you see this blast of plasma, which is mostly protons and electrons, zipping out into space with an embedded magnetic field. If that happens to be pointed at Earth, it can arrive at Earth. And if the embedded magnetic field inside that CME, when it arrives at Earth, is the right polarity or the right alignment with Earth's magnetic field, it can do all sorts of interesting things, like collapse our magnetic field inward, and potentially cause harm to satellites. And then the protons and electrons then can follow the magnetic field lines down to the polar regions, and they can also create what's called a magnetic reconnection event, which I won't get into. That gets way too messy. But when all that happens, it produces what we see as northern and southern lights. And it's a spectacular event to see, and a spectacular phenomena. So if you haven't seen one, oh yeah, you'll be amazed, particularly if you are able to see it from up north in Canada or Alaska. The best places to look for the northern lights in Colorado is in a dark sky location. So rural areas out in the plains, away from the city lights of the Denver metropolitan area, places like Estes Park and other places tend to be better for that. And usually here in Colorado, unless it's a really, really significant event, and where let's say the KP index gets up to 8 or maybe even 9, which would suggest we could possibly see that even with city lights, but that kind of, it depends. But usually the northern lights will show up on the northern horizon, and we may see a reddish glow or a greenish glow, which is what a lot of people caught. And of course, if they happen to have a camera that can be set up on a tripod and do a long exposure photo, then they might see a bit more color than you can with the naked eye. There's so many people that have never seen them. They rank up there on number 2 on my personal list of astronomical phenomena that should be on everybody's bucket list. Total solar eclipse is number 1, but the northern lights are number 2, and a close number 2 for me. It's one of those things you'll never forget. Especially first time was in Canada back in the 1960s. And to me, I remember seeing that and thinking that looked like colored dancing curtains in the sky. It just absolutely blew my mind. And I've seen them on occasion since then over the years too, including from up in Alaska and elsewhere. They're mind blowing. They're absolutely mind blowing to see.